Hello, I'm Vivek. Yeah. Hello, I'm Vivek, and in this video, we are going to see the solution of our first AI test, right? So, in this whole video, we are going to solve some important questions that in which some student may facing some problem or issue, right? So in this I'm going to give you an entire solution for this first AIET test. I accept कि सबका एग्जाम बहुत अच्छा गया होगा, बहुत अच्छा एग्जाम सबने किया होगा, सारे क्वेश्चंस अटेम्प्ट किए होंगे. सो आज चलो देखते हैं फटाफट और सभी सॉल्यूशंस को करते हैं. एंड बस और देखते हैं किसी को कोई भी प्रॉब्लम होगी इससे रिलेटेड तो उसको भी तुम रेक्टिफाई कर लेना, राइट? सो इन दिस वीडियो वी आर गोइंग टू सॉल्व ईच एंड एवरी क्वेश्चन. आई एम ट्राइंग टू सॉल्व ईच एंड एवरी क्वेश्चन, एंड दिस whole video will of 1 hour maximum, in which we are trying to cover all this question, right? So let's start with the first question what we have. So पहला क्वेश्चन जो हम लोग के पास था वो क्या था? That is, how much energy is required to move an electron from the ground state to the hydrogen atom to the first excited state? So this question is from the Bohr model, right? So in Bohr model we know the expression for the energy. That we know the expression for the energy, that is this is equal to nothing but minus 13.6 upon n square in terms of electron volt. So this formula we already know, right? Where n decide the number of the shell. Here we also use Z square, where Z is the atomic number, right? For hydrogen atom, it's always equal to 1. So how much energy is required to move an electron from the ground state of the hydrogen atom to the first excited state? What do you mean by the first excited state? First excited state means here n is equal to 2. So here in this case n2 is equal to 2, and the ground state is nothing but n1 is equal to 1. So from here to here, from ground state to the first excited state, that is N2, how much energy you required, है ना? So let's see how much energy will be required. So we know that what is the energy change. So energy change comes out to be nothing but E2 minus E1. What is E2 here? So for E2, we put the formula because here Z is equal to 1 because this is for hydrogen atom only, no? So this comes out to be that is minus 13.6 divided by n square. So this is the 2. That is 2 means that is 4. Right. So this comes out to be 4 minus again 13.6. Again one minus sign we use, and this is 1. So on solving what you'll get, that is nothing but 10.2 electron volt. So which option is correct? Here it says that is C. So option C is absolutely correct. I hope सबने यही किया होगा. This is very simple question, है ना? चलो नेक्स्ट देखते हैं. सो इन द 47 क्वेश्चन, which of the following sets of quantum number is correct for an 4f orbital? So we know that if I'm talking about the quantum number, we have a four set of quantum number, that is n, l, ml, and that is ms, right? So 4f, so in 4f here what is n? So n is equal to 4. What is l beta? So we know that 0, 1, 2 and 3. So 0 represent S, 1 represent P, 2 represent D, and 3 represent F. So this is asking specifically about F now. So here the value of L is nothing but 3 only, right? Not 0, 1, 2. So value of L is 3 only. So let's see the option. N is equal to 4 and L is equal to 3. So N is equal to 4. No, no, no. So only this, yeah. N is equal to 4, L is equal to 3. So this option will be happening, huh? And we know that ML values line from minus L to plus L. So if the value of ML is 3, so obviously ML is minus 3 to plus 3 only, na? है ना? So only plus 3. So this one is, which one is correct? This one is correct? Yeah. This one? Yes. So only of this one is correct because M cannot be 4. Right? ML can be minus 3, minus 1, minus 2, 0, 1, 2, or 3, but it cannot be 4 because L is only 3. So the correct option for the question number 47 is nothing but A. Clear? Sure. Now, move to the next question, that is question number 48. Arrange the element in the increasing order of their atomic radius. That is, we have a sodium, rubidium, potassium, and magnesium. So this question is from S block. So we know that down the group size increases. So we have a lithium है लीना की तरफ से फरिया. So lithium, sodium, potassium, rubidium, and cesium we have, right? And the in second group we have also magnesium. Hmm? Chalo. So if I'm talking about the size, When you move down the group, size increases, and we move from left to right, size decreases. So out of these, the one who having longest size is nothing but the rubidium, right? So rubidium is the longest. So all three options contain rubidium except the B. So just neglect this. And after rubidium, we have a potassium, sodium, and lithium. So after rubidium, we have a potassium, sodium, है ना? And this magnesium. So again, this is A, right? Because the magnesium belongs to the second group in the third period. So it is the smallest one. So what is the correct order? That is magnesium, sodium, potassium, and higher. Which one is the highest and largest in size? That is rubidium. So 48. It's a very simple question. Now, move to the next question. That is question number 14, right? So which of the following arrangements represent the correct order of magnitude of electron gain enthalpy of the given atomic species? So in this question, you want to, just calculate, want to represent this according to their electron gain enthalpy. So we know that electron gain enthalpy means tendency of an element to, uh, gain one electron to become stable. So generally, electron gain enthalpy become more and more negative when you move from left to right in the periodic table. Okay, but in case of fluorine and chlorine, because of the smaller size, it's accepted to be fluorine showing negative electron gain enthalpy than the chlorine. But in actual, chlorine having more electron gain enthalpy negative than the fluorine. Why? Because the size of fluorine is very small, and when an extra electrons come and add on them, they provide repulsion. Due to this, the negative gain enthalpy of fluorine is much lower than that of chlorine. Okay, so what is the correct order for this? So out of chlorine and fluorine, which will show most negative gain enthalpy, that is chlorine. So this one is wrong. This one is correct. And out of oxygen and sulfur, which will show sulfur. So definitely which option is going to be correct? That is D, because we know that oxygen, sulfur. So these all are the exceptional cases. Oxygen, sulfur, expected gain enthalpy will be oxygen, but in reality, sulfur. Reason is same, just like a fluorine and chlorine. है ना? So option B is the absolutely correct option. Now, let's move to the question number 50. So using MOT, compare O2 plus and O2 negative species and choose the incorrect option. So you have to choose the incorrect option by using MOT theory. Okay. So if I'm talking about O2 plus, so O2 plus is a diamagnetic. First of all, O2 plus. So what is O2? O2 having number of electrons in O2 is equal to 16. So what is the number of electron in O2 plus? So 16 minus 1, that comes out to be 15. Okay, this is the odd number of electrons. Remember this, odd number electrons. Similar O2 negative. So O2 we know, O2 we have a 16 plus 1, that's come to 70. 70 is also odd number. Hmm? Hmm, good. So using MO2, compare O2 and O2 species and choose the incorrect option. So O2 plus having a higher bond order than O2. Let me calculate the bond order. So we have a trick to calculate the bond order. We know 14 bond order is 3, and for the 15 bond order is 2.5. 16 we have a bond order like 2, and for 70 we have a bond order like 1.5. So we have a 15 and 17. The 15 having bond order 2.5 and 17 having 1.5. So O2 plus having higher bond order. Yeah, this is the correct. O2 is the less stable. Yeah, correct. Both O2 and O2 are the paramagnetic. Yes, because both are odd number of electrons. So both are the paramagnetic. So only option C is incorrect here because O2 is a diamagnetic. So O2 plus is a 50 number. It is an odd number of electrons. So why this is a diamagnetic? It's supposed to be paramagnetic, and it is paramagnetic. So therefore the option C is correct according to this question, because in this question you have to identify the incorrect option. So this is only the incorrect option. Okay. Good. Now, the next thing is, at what temperature will the average speed of CH4 molecule have the same value as D2 as at 300 Kelvin? So in this question, basically this question is from the states of matter, right? So at what temperature will the average speed of CH4 molecule have the same value as D2 has at 300 Kelvin? So we know that, we know how will you calculate the velocity? It is nothing but that is 3RT one we say rather than, and we have the formula, right? This root is big m1. Similarly for c2 we calculate like this, comes out to be 3rt2, and this is equal to m2. So m1 is the molecular mass of d2, which we know that is 4. And what is m2? M2 is the molecular mass of ch4. So we know that m1 is the molecular mass of D2, D2 molecular mass. So what is the value of this? The value is nothing but 4. Hmm. And similarly, M2 is the molecular mass of CH4. So molecular mass of CH4, it is equal to 16. So this comes out to be 16. And temperature we all know. So just put the value, what you will get. On putting the value, what you will get better? Because we know one temperature, that is 300 Kelvin. We know the R cancel, 3R cancel, M1, M2, you know. So just solve this, you'll get the T2 values, comes out to be 1200 Kelvin. Right. So this is also a very, very simple question. Now, the next question is the ratio of the rates of diffusion of hydrogen chloride and ammonia gas is. Okay, so ratio of rates of diffusion chloride and ammonia gas is. So in this, you have to calculate the ratio of the rates of diffusion of hydrogen chloride and ammonia gas. Okay, so this question is from the diffusion. So let's solve this value. We know that for diffusion, how will you find this? We know that the rate of diffusion, for example, if I'm talking about the rate of diffusion of HCl and the rate of diffusion of NH3, so rate of diffusion is equal to nothing. But how will you find this? We have a formula, right? So we have a formula like molecular mass of the NH3, reciprocal of molecular mass rate of diffusion, right? And this is the molecular mass of HCl. So just put the value, you'll get the answer, है so what is the molecular mass of NH3? That is 17. HCl, that is 35.5. So this comes out to be nothing but 1.146. Right? So on solving, you'll get this value 1 upon 1.46. So which one is the correct answer, beta? 52. That is A. So this one is the absolutely correct answer. So I hope सबको समझ आया होगा यहाँ तक किसी को कोई प्रॉब्लम नहीं होगी बहुत सिंपल क्वेश्चन है ना गुड चलो अब देखते हैं 53 क्वेश्चन की 53 क्वेश्चंस क्या रिक्वायरमेंट है भाई 53 क्वेश्चंस की सो द रेट ऑफ डिफ्यूजन ऑफ टू गैसेस दैट इज ए एंड बी आर इन द रेशियो 1:4 and those of B and C in the ratio 1:3 the rate of diffusion of C with respect to so diffusion of A and B are already given and the B and C are in the ratio 1:3 you have to find the rate of diffusion of C with respect to A chalo so how will you find the rate of diffusion of this. Okay, so we know that the rate of diffusion of AB, okay, so this is equal to 1 by 4. They are having ratio 1 by 4. Similarly, rate of diffusion of B by C, they are in the ratio 1 by 3. Just multiply this R in RA upon B into RB into C. They comes out to be R A R B R B R C. RB cancel, you'll get RA by RC. So RA by RC is equal to 1 by 4 into 1 by 3. Comes out to be 1 by 12. Right. So which option is correct? That is option number A. So 53 having option A is absolutely correct. Okay. Now let's move to the thermodynamics. Okay. So based on the first of thermodynamics, which one of the following is correct? Right. You have to identify which of the following is correct one. So for an isochoric process, delta U is equal to delta U is equal to minus Q. Is that true? Okay. Let me write the first law. That is delta U, that is delta Q plus W. So for the isochoric process, delta W is equal to 0. So delta U is supposed to be equal to delta Q. No, this is wrong. For an adiabatic process, delta U is equal to, this is absolutely wrong. This is for adiabatic process, right? So for the adiabatic process, Q is equal to 0. So delta U is equal to W. So this is also wrong. For an isothermal process, delta U is equal to 0. So Q is equal to minus W. So this is also wrong. For the cyclic process, Q is equal to delta U because the cyclic process, delta U is equal to 0 because this is a state function. So Q is equal to W. So option D is absolutely correct. So for the question number 54, D is absolutely correct. समझ आया सबको क्योंकि साइक्लिक प्रोसेस है ना साइक्लिक प्रोसेस के लिए डेल्टा यू क्या होगा भाई डेल्टा यू तो होता है फाइनल माइनस इनिशियल वो तो दोनों सेम हो गया दैट्स व्हाई डेल्टा यू बिकम 0 एंड क्यू जो होगा वो माइनस डब्ल्यू के इक्वल है चलो now, move to the question number 55. This one is also very important, and this question is from the again thermodynamics Hess law. So this is given S plus 3 by 2 O2. This is SO3, 2x kilojoule of heat is released, and this is SO2 plus half O2, SO3, y kilojoule of heat is released. So from the given reaction, predict the heat of formation of SO2, right? So you have to, in this reaction, predict the heat formation of SO2. So let's see heat formation of SO2. So what is the aim here? How will you prepare SO2? So we know that SO2 is nothing but S plus O2. This will gives us SO2, right? SO2. And let's see, delta H for this is nothing but minus Z kilojoule. Hmm? Chalo. Now we have this is our aim. Okay, this is our aim. Now, what data we have? We have S plus 3 by 2 O2. This gives us SO3 plus 2x kilojoule. And this is SO2 plus half O2. That is equal to SO3 plus y kilojoule. Chalo. Now you have to identify this. So from these two equation, how will you find this? We have to find SO2 only now. So from these two equation, how will you find this? So just if you just observe this, if you I just name this, that is delta H1. Hmm. And this is named as delta H2. And this is delta H3. So nothing, just add what you want to do. Just add delta H3 plus delta H2. You will get delta H1. So what is delta H3? That is nothing but minus Z. This is Y and this is minus 2x. So what is Z? So Z comes out to be 2x minus y. So which option is correct? There is a 2x minus y. That is C. So option C is absolutely correct. चलो अगले क्वेश्चन पे चलते हैं. That is 56. Again, this question is from the Heslop. So this question is again from the Heslop. So let's see the solution for this. So you have to identify the enthalpy formation of C2H2. So what is the enthalpy formation of C2H2? ठीक है, कैसे निकलेगा ये C2H2 का एंथैल्पी फॉर्मेशन? तो चलो देखते हैं फटाफट कि H2O2 का कैसे कैसे निकलता है, कैसे नहीं. So enthalpy formation of C2H2. So what is the aim here? Can anyone tell me what is the aim? So here aim is nothing but C2. It means we want C, that is 2C, and plus H2. So this will give us C2 H2. So how will you, from these two equation, how will you observe this? 2C we have this side, H2 we have this side, and C2H2 we have this side. But we want from this, we want this from the right hand side, right? So just nothing, just to add equation. जब भी ऐसे क्वेश्चन होते हैं जस्ट ऑब्जर्व करो कि क्या दे रखा है. तो 2C इधर दे रखा है, 2C हमें इधर ही चाहिए. H2 इधर दे रखा है, H2 इधर ही है. लेकिन C2H2 इधर दे रखा है बट हमें चाहिए प्रोडक्ट के साइड. तो उस इक्वेशन को माइनस करो और बाकी दो इक्वेशन को ऐड करो. तो ऐड इक्वेशन 1 plus 2 and subtract with minus 3. You'll get the answer, right? You'll get the C2CH plus H2 is equal to C2H4. So just do this. That is nothing but the first one is what the first value? Yeah. So just put the value like the first equation we have, that is minus 786.4. Again we have minus 285.8, and this way plus we have a 1297, right? So we have a 1297 and this, they'll get 224 around. So 224.8 kilojoule. So this is the correct one. So the correct answer is A, that is 224.8 kilojoule. This is absolutely correct. ठीक है, चलो question number 57. So this question is from the Lee Chatterjee principle from the chemical bonding, and one of the very important topic in the chemical equilibrium part. So what the question asks, the yield of the product in the reaction will be higher. So this is the product yield they are asking. So basically this reaction is the exothermic or endothermic. Can anyone tell? Yeah, this is a exothermic reaction, right? So this reaction is a exothermic. Okay. So for exothermic, low temperature is required. So for exothermic, always low temperature is needed. Now, how will you talk about the pressure in terms of number of moles? So here the number of moles is 1 and 2, that is 3. So here number of mole is 3. Here only one number of mole is there. So if you increase the pressure, then the equilibrium shift in the direction where number of mole is less, that is in forward direction. This is the desirable condition. So high pressure and low temperature. So low temperature and low pressure, low temperature, high pressure. Yeah, option C. That is low temperature and the high pressure are the favorable condition. Because already whenever pressure comes ना, जब भी pressure आता है तो क्या सोचना है, number of moles देखो, इधर number of moles कितने हैं 3, इधर number of moles कितने हैं 1. तो लीच एटलीट क्या कहता है कि when you increase the pressure equilibrium shift in a direction where the number of moles is less, है ना, वो हमेशा पोज करता है. तो नंबर ऑफ मोल्स किधर कम है, दैट इज प्रोडक्ट साइड ना, और ये तो हमारी डिजायर कंडीशन है कि प्रोडक्ट बने. That it means low temperature and high pressure. That is 57C, right? So this having the correct answer. Low temperature and high pressure are the desirable condition for this. चलो 58 क्वेश्चन. चलो 58 क्या कहता है, द इक्विलिब्रियम कांस्टेंट फॉर द रिएक्शन इज 0.008 at 300 Kelvin. The standard free energy change of the reaction at the same temperature is. So the equilibrium constant for the reaction is given 0.008 at 300 Kelvin. The standard free energy change of the reaction at the same temperature is. So how will you find this beta? चलो देखते हैं. So we know that we use a simple formula for this question, and we know that that is the Gibbs formula, है ना, Gibbs free energy. So what is the formula for the Gibbs free energy? That is delta G naught is nothing but is equal to minus 2.303 RT. This is log K. So delta G naught is equal to minus 2.303 RT log K. So just put the value here. So 2.303 here. What is the value of R? That is 8.314. What is temperature? 298. What is this? Log. What is the value of K? That is 0.008. That is 0.008. So just solve this value. You'll get the answer. So you'll get the answer like minus 11,500 joule. But in kilojoule, that's divided by 1000. So 11.5. Which one is correct, beta? That is D. So this one is the correct answer. Plus value we need now. So this is absolutely correct answer. Okay. Now, next question, the volume strength of 1.5 normality H2O2. So you have to find the volume strength of 1.5 normality H2O2. So here in this question, normality is given and this is equal to what? That is 1.5. So normality is given. This is equal to 1.5. So what is the normality here? So normality is given, that is equal to 1.5. We know that the equivalent weight of H2O2 is 70. So the equivalent weight of H2O2 is nothing but 17. So equivalent weight of H2O2 is 17. Okay. And normality is 1.5. So equivalent weight of H2O2 is 17 and the normality is 1.5. Okay. So what is the strength? So we know that strength is nothing. Strength is nothing but normality into equivalent weight. So normality is equal to 1.5. Equivalent weight is equal to 17. So this comes out to be beta 25.5. Very good. So this comes out to be 25.5. Now, therefore, we can say just write the reaction of H2O2. That is 2H2O2 decomposed to give 2H2O plus O2. It means 68 gram, है ना, ये वाला. That is 2 into 34. ठीक है. So 68 gram. Okay, 68 gram of H2O2 at NTP, है ना, normal temperature and pressure, produce 22.4 liter. 22.4 liter. ठीक है, 22.4 लीटर ऑक्सीजन. सो 25.5 को कितना लगेगा भाई? 25.5 कितना बनाएगा? एक के लिए कर लो, 22.4 डिवाइडेड बाई 68 into 25.5, right? So this value comes out to be, जल्दी बोलो, that is 8.4 liter. So that is 8.4 liter of, or we say oxygen. So 8.4 liter. Which option is correct? That is B. So B is absolutely correct answer for this question. Okay, let's see the next one. That is question number 60. So what the 60 question asks? So if the X volume of H2O2 means that 1 liter of H2O2 gives X liter of O2. Yeah, this is the meaning of, strength of the hydrogen peroxide. then the strength of 10 volume of H2O2 solution is. Hmm? Then the strength of 10 volume of H2O2 solution is. Now, let's see. So let's see the solution for this. So we know that 10 volume of H2O2, 10 volume of H2O2. And 10 volume of H2O2 means what? 10 volume of H2O2 means, है ना? 10 volume of H2O2, है ना? So 10 volume of H2O2 means 1 liter of H2. So 10 volume of H2O2 means that 1 liter of H2O2 gives 10 liter of O2 at STP. This is what they mean. है ना? 10 liter of O2 at STP. Now again, you just write the formula. So we know 68 gram gives 22.4 liter. 22.4 liter. So 22.4 liter, 68 gram. So 10 liter will give. 10 liter will give how much? So one will give 68 upon 22.4 into 10 liter. So this is what they have. So this will comes out to be how much? That is 68 upon 24 upon 10. That is 30.36 gram. And 30.36 gram. So that comes out to be 30.36 gram. So which one is the correct? 30.36. That is D. So option D is absolutely correct. Now, question number 61. Which of the following equation depict the oxidizing nature of H2O2? So which will show they are the oxidizing in nature. So you just observe option number C very carefully. Here the oxidation state of I is negative, that is -1. And here the oxidation state of I, right? Here the oxidation of state of I become 0. So -1 to 0, oxidation takes place, right? So this equation will show the oxidizing nature of H2O. Now, which of the following oxide is amphoteric? So in this question, they are asking which of the following oxide is amphoteric in nature. So you have to identify the amphoteric oxide. So out of these, we know that SnO2, because if we know the group, this group, carbon, silicon, germanium, tin, lead, है ना? So these two generally use in making semiconductors, है ना? So Sn, है ना? So that is SnO2. They are the amphoteric nature because they react both acid. They react with both acid and base. So we can say that they are amphoteric in nature. चलो तो ये तो हो गया. चलो. Next 64. So which element has the least electron active in group 13? So we have a group 13 element, list of a group 13 element like bangan, aloo, gajar, in thalam. So this is the way to remember this group, bangan, aloo, gajar, in thalam. है ना? So we know that down the group, electron activity decreases, right? So when you move down the group, electron activity decreases. However, which element has the least electronegative? So which one is the least electronegative? Because basically metals are the more electropositive. So which of the following is the most metallic character? That is aluminium. So aluminium is basically the least electronegative in the group 13. Good. Now move to the next question. That is 65 question. So this question is from the empirical formula and the molecular formula base. Very simple question. Let's see the percentage of CNH are given 40, 30, and 46. The empirical formula, what you need. So we know that first of all, what we write the name of the element. That is, this is nothing but carbon. We have a carbon, we have hydrogen, and we have nitrogen. So three elements we have. Now we have a percentage of each element. Carbon having 40%. Again, this hydrogen having 13.3% and nitrogen having 46.7%. Yeah, good. Atomic mass of carbon we know, for example, carbon 12, hydrogen 1, nitrogen 40. You can calculate mole very easily. So mole comes out to be 40 upon 12. Again 13.3 upon 1. Again 46.7 upon 14. So their values comes out to be, this comes out to be 3.33. That comes out to be 13.3 and this again 3.3. So always try to select the value which comes lower. सो इसमें तो दो वैल्यू सेम है, वैसे हमेशा हम कम वैल्यू को सेलेक्ट करते हैं, जो भी कम वैल्यू होता है उसको हम डिवाइड कर देते हैं पूरी इक्वेशन से, तो ऑलवेज सेलेक्ट द लोअर वैल्यू। सो इन दिस क्वेश्चन टू वैल्यूज आर सेम, सो नो वरी, जस्ट सेलेक्ट आइदर ऑफ देम, not a problem. So just divide by them, so it comes out to be 1, it comes out to be like 13.3 divided by 3.3, so it comes out to be 4, this is again 1. So formula is be like that is C1, and H4, C1H4N. So this is the formula CH4N. So option C, है ना? So 65, option C is absolutely correct. So for the question number 65, option C is correct. चलो, let's move to the question number 66. That is the correct stability of the order of the following resonating structure. So you have to find the stability or structure, है ना? So let's see the that is the correct order of the stability order. So if you consider this, that is B, that is one having the more stable resonance structure, right? So lower is the charge separation, greater is the stability. Always remember this. What the mantra for this? Lower, lower charge separation, meaning lower is the charge separation, lower is the charge separation, greater is the stability, greater is the stability, है ना? So lower is the charge separation, greater is the stability. So always remember this formula only. So which one is the stable? That is this 1, 3, 2, and 4. So this is the correct stability order for the following resonating die. Chalo. Move to question number 67. You have to classify the correct IUPAC name of the following compound. So what is the correct IUPAC name of the following compound? So let me write the correct IUPAC name of the following compound. That is the just name the out of this BH, OH and BR. OH is a functional group. So this is the name is 1, 2, and 3. So in 3 we have a bromo. So this is 3, and 1 we have a substitute like phenyl. So just write 3 bromo, 1 phenyl, and the propanol. So this is the correct IUPAC naming. This is very simple. Chalo. 68 question. So in the question CH2, double bond CH, CH, CH2, and Br2. So this is the addition reaction. So the addition of conjugate diene at 40 degrees Celsius always give 1,4 di-addition product. Okay, 1,4 addition product. So which one is the correct? That is B. 1,4 dibromo 2-butene. So always they give 1,2 di-addition product. Chalo. Next move to the question number 17. What the question asks? 2-methyl butane on reacting with bromine in presence of sunlight. So we have a 2-methyl butane. So just me draw the structure of this 2-methyl butane. We have a CH3, CH. Again we have CH3, CH2, and CH3. And we react with Br2. Br2 and H mu. Okay. So react with Br2 and H mu. What you will get, beta? We'll get like CH3. This is C. Again, at this position, we'll get Br. This is again CH3. This is CH2, and this is CH3. Okay, this is because the order of structure of H plus atom from alkene is always follow this order. That is all सबसे ज़्यादा 3 degree, 2 degree, and then 1 degree. So only this carbon is 3 degree in nature, है ना? This is 3 degree in nature. That's why this reaction will take place at this carbon only. So this is what we get, that is 3 degree, 2 degree, and 1 degree. So this is all about. Okay. So I hope this is clear to you that how will you get the value like 3 degree, 2 degree, and 1 degree. Chicken. Good. So this is how will you get this value. So this is for question number 70. Now, similar for question number 71. So if the 30 ml of H2 and the 20 ml of O2 react to form water, what is left at the end of the reaction? So in this question they're asking if the 30 milliliter of H2 and 20 milliliter of O2 react to form water, what is left at the end of this reaction? So they are basically asking you at the end of the reaction, what is left and which one behave like a limiting region. So this question is from stoichiometry, limiting region part. So let's write the equation first. So we have 2H2 plus O2. And this 2H2 plus O2 will gives us 2H2. Hmm? Okay. So here the initially it is given that is two volume, one volume. So according to the Avogadro law of stoichiometry can be understood in the terms of volume as well as since the number of moles of gas is directly proportional to the volume. So two volume of H2 react with one volume of O2 to give the water. So we can say that 30 ml of H2. So two volume of O2 will react with one volume of O2. So we can say that 30 ml of H2 will react, right? 30 ml of H2 will react with 50 ml of O2 only. Hmm? 50 ml of O2. Hence, H2 is a limiting region. So it is very much known. H2 is limiting region. H2 is limiting region, right? 20 ml of O2 we have now, but they require 50 ml of O2. So we know that H2 is a limiting reactant. So if the H2 is a limiting reactant, so what is the volume of O2 left unreacted? So the volume of O2 remain unreacted. Okay, the volume of O2 left unreacted is nothing but 20 minus 15, which is comes out to be 5 ml. Hmm? So this is exactly equal to 5 ml. So what is the correct answer for this question? That is 5 ml, right? So that is 5 ml of O2. 5 ml of O2 is the correct answer for this question. I hope this is clear to you. Hmm? Chal. What is the mass of the precipitate formed when the 50 ml of 6.9% W by volume weight solution of AgNO3 is mixed with 50 ml of 5.8% weight by volume NaCl solution? So we have a molecular mass Ag 108, Na we have a 23 and our molecular mass is given. So you just need to calculate this value. है ना? Chalo. So how will you find this value beta? So we know that how will you just write the reaction of this? So we know that AgNO3, है ना? So this AgNO3 react with NaCl. So what they form? They will form AgCl plus NaNO3, right? So this AgNO3 plus NaCl react, they will form AgCl plus NaNO3. So initially at T is equal to 0, right? At T is equal to 0, the number of mole of NaCl3 is what? That is nothing but 8.45 mass and their molecular mass that is 170. So it comes out to be 0.05 mole. Hmm. Now, after it initially NaCl, the mass is given. Molecular mass we know that is 58.5. So number of mole is nothing but 0.05 mole. Okay? And this is 0 and 0. Now, finally, at T is equal to final time. Okay? Final time. So this AgNO3 will 0. है So this becomes 0. This becomes 0. This becomes 0.05 and 0.05. Okay, so the mass of AgCl precipitated. So what is the mass of AgCl precipitated? So mass of AgCl precipitated is nothing but 0.05 into molecular mass, that is 143.5. So it comes out to be 7 gram. Okay, so 7 gram is the correct answer for this. That is option B. So correct answer for this question is answer B. I hope this is clear to you. How will you find this? Chal. Next, move to the question number 73. That is at 25 degrees Celsius, the highest osmotic pressure is exhibited by 0.1 molar solution. So, which of the following exhibit higher osmotic pressure, right? So, we know that osmotic pressure pi is nothing but CRT into Vent-Off factor. This one is very important, Vent-Off factor. So, out of these, this having Vent-Off factor 1 because they are the covalent compound. Again, urea is again I is equal to 1. For KCl, we have a K plus and Cl negative. So I is equal to 2. But for CaCl2, we have a Ca plus 2Cl negative. So in this case, we have a I is equal to 3. So I is more in which case? That is CaCl2. So obviously CaCl2 will show the highest osmotic pressure. Hmm? Sure. No, 74 question. That is 25 gram of each of the following gases are taken at 27 degrees Celsius and 600 millimeter pressure. Which of this will have the least volume? So you have to identify which of the following has the least. So HI has the least number of mole, as we say that 25 gram each of the following gases. Huh? So each of the following gases and divided by their molecular mass. So we'll get the which of the following has the least volume. So which of the following has the least volume, beta? HI, right? So basically, HI has the least number of moles, therefore the volume occupied by is least, right? So that's why the volume occupied by this is least. Okay, so I hope this is clear. Good. Now move to the question number 75. That is the elevation in boiling point. This question is from the elevation in boiling point qualitative property solution chapter. So the elevation in boiling point of the solution is 13.4 gram of copper chloride in 1 kilogram water. Using the following information will be. So you have to just calculate the elevation in boiling point. That is delta TB. So we know that what is delta TB. So delta TB is nothing but molality into Kb into I. So this is what we need. है ना? Okay, so let me calculate molality. Number of moles divided by per kilogram of the solvent. So 1 kilo. So here in this 13.4 gram. है ना? So molality is nothing but 13.4 gram. This mass of the solute, that is 13.44 gram. Calculate the molecular mass of this. So it comes out to be 134 point, Hmm. So just calculate the molecular mass of this. This is 63 and 35, 70, 71. है ना? So 71 plus 63, 3 and 4. और 3 एक 4 हो गया, 7 6 13 14, 144. So molecular mass is 144 into 1000 divided by 1000. So this is the molarity. Hmm? 134 or how much? This is 63.5 now. So this is 3 and 1 4. Okay. 134.5. Sorry. 134.5. So this comes out to be 134.5. And what is KB here? 0.52. What is I? You need Y? Yeah, because we have a copper chloride. So I is equal to 3. Can you calculate this? Copper chloride, just like CaCl2, 1 copper and 2 chloride. So we say I comes out to be 3. So just put the value, you'll get delta T. So delta T comes out to be 0.16. So 0.16, yeah. Option A is absolutely correct. Now, if a force of sucrose, if for a sucrose solution, elevation in boiling point is 0.1 degree Celsius, then what will be the elevation in boiling point of NaCl solution for the same molar concentration, assuming NaCl undergo complete dissociation? Okay. So if for the sucrose solution, right, they undergo complete dissociation. So let's see the solution for this. We know that delta TB, again, this is very much similar question, just like the previous one. That is delta TB is nothing but I into KB into M. So this is the basic formula for this. Hence, elevation boiling point is directly proportional to the number of solute particle, right? Since the dissociate completely, the number of solute particle in NaCl solution is double than that of the glucose solution, right? Because we know that in NaCl, Venter factor comes out to be what? 2. 1 Na and Cl. But in glucose, the Venter factor comes out to be only 1. So their property becomes twice. So they having the sucrose elevation boiling point 0.1. So for sucrose, if they are 0.1, then for NaCl, it will become 0.1 into 2. That is 0.2. Because we have a 2 Na and Cl to 2 moles. So we can say that. So B हमारा सही होगा क्योंकि NaCl 2 में टूट गया तो I की वैल्यू 2 आ गई जबकि वहां पे तो I 1 ही था इसीलिए ट्वाइस हो गया जितना उसका था. So ये question हो गया. Now move to the question number 18. In a mixture of A and B, components show negative deviation. So for negative deviation means what? If the vapor pressure comes out to be less than what we expected from the Rawls law. So this will happen only when the force of attraction between the two liquids are more, right? If the force a solute solvent attraction is more, so AB interaction is stronger than AA and BB, yeah. So then only this will be happen. So the correct answer is A, because in this the solute solvent force of attraction is more as compared to the solute solute and solvent solvent. So less vapor will be formed. Now move to the next question, that is 81. So 2.5 liter of 0.1 molar NaOH solution is mixed with the 3 liter of another solution of NaOH, right? So let's see the solution of this. Just wait. So 2.5 liter of 1 molar NaOH solution is mixed with the 3 liter of another solution of NaOH that has a molarity. Find out the molarity of the resultant solution. So this question is done from the molarity equation only. बहुत simple है. 81. So we know that for molarity equation, we know that M1 V1 M2 V2, and this is equal to V1 plus V2, and this is M. So find out the molarity. So we have a 2.5 liter of, so just multiply 2.5, and molarity of the first solution is 1. Similarly, that is a 0.5 molarity and volume is 3 liter. So and this is volume is 3 plus 2.5. And this is the M. So just calculate M, you'll get this value, right? It's a very simple one. It comes out to be 0.73 molar. So this is the correct one. 0.73 C. So option C is absolutely correct. Now move to the question number 82. So the average osmotic pressure of the human blood is 7.8 bar at 27 degrees Celsius. So this is the average osmotic pressure of the human blood, which is equal to 7.8 bar at 27 degrees Celsius. What is the concentration of an aqueous NaCl solution that could be injected in the bloodstream? So the average osmotic pressure of the human blood is 7.8 bar at 27 degrees Celsius. What is the concentration of an aqueous solution of NaCl that could be injected in the bloodstream? So you have to find this value. So we know that, let me calculate here. यही कर लेते हैं. So pi is equal to, again we know, I CRT. So for NaCl, I is equal to 2, है ना? NaCl अभी बहुत बार निकाल लिया हम लोगों ने, तुम्हें आ गया होगा. 2 ions are there, ना? That's why. So I is equal to 2 for the NaCl. So we know that 2. Here concentration is given क्या? Concentration तो निकालना है. So this is C. What is R? So we already taken R na, 8.314. And what is temperature? Temperature is 27. That comes out to be 300. Right. And pi is given 7.8 bar. So it's a very simple question. Just you have to calculate the C. So just solving, you'll get the C. It is equal to nothing but this comes out to be 0.16 mole per liter. So this is the correct answer. Right. So this is the this one, that is C, concentration. Now, so this question is also very, very, very important. This question is also from the elevation, boiling point, and depression freezing point. This question is from the previous year itself. Right. So the two element A and B form the compound having molecular formula AB2 and AB4. When dissolved in 20 gram of C6H6, 1 gram of AB2 lower the freezing point by 2.5 Kelvin, where the 1 gram of AB4 lowered is by 1.5 Kelvin. The molar depression constant for benzene is given 5 kg per mole. What is the atomic mass of A and B respectively? So you have to identify the atomic mass. Now, I would say, observe very carefully. This one is very important question. So suppose the atomic mass of A and B are, so let us assume atomic mass of A and B is X and Y. ठीक है, X and Y respectively. What is the molar mass of AB? So the molar mass of AB 2 is nothing but X plus 2Y. Because A का X है और B का Y रखा है, तो B2 तो 2Y, right? So 1 gram of AB2. How will you calculate the number of mole? Mass of the solute, that is 1 gram, upon में molecular mass, that is x plus 2y. ठीक है? Similar, molar mass of AB4, that is x plus 4y. So what is 1 gram? X plus 4y mole. Sure. So we know if you want to calculate the molarity of AB2. So molarity of AB2 is nothing but mass 1 upon x plus 2y. So this is the mole divided by the mole. Na? This is the mass of solid upon molecular mass, right? And this is 1000, and mass of solvent is nothing but 2. So on solving, what you get? You get 50 upon x plus 2y, right? So this is the molality. Now we know that what is delta TF. So delta TF is what? That is KF into molality of AB2. So KF is equal to what? You know the value of KF? This is given. This is already given. So molality of AB2. So because TF2 is already given now, and KF is also given. So this comes out to be, just put the value of MAB2. This comes out to be 50 upon x plus 2y. So on solving, what you will get? You will get x plus 2y is equal to 100. This is equation 1. Similar for the second case. Just similar. Similar on solving the second case, what you will get? X plus 4y is equal to 5000 divided by 3. So just solve these two equations. You will get the value of x and y. So on solving your equation, you will get x is equal to 33.3 and y is equal to 33.33 gram per mole. Again, gram per. So 33, 33. So which option is correct? 83. So the correct answer is now. Move to the next question. That is 85. The solution containing 10 gram per decimeter cube of urea having molecular mass 60 gram per mole is isotonic with the 5% solution of non-volatile solute. You have to calculate the molecular mass, right? So just calculate the molecular mass. So this is very simple. 10 gram per decimeter cube solution contain urea having molecular mass of this. Isotonic means what? Their osmotic pressure is same. So pi is equal to pi dash. Okay, so just put the value according to this. That is pi is equal to pi dash. So we know that this is CRT is again CRT. R and T remain same. Just yeah. So only have to calculate C and C dash. What is C? That is N upon V. What is this? N upon V. Now again, what is N? So N is equal to mass upon molecular mass. Volume get cancelled. Okay. This is again mass upon molecular mass. This is for dash. So this is for mass, molecular mass, dash, dash, and this is mass. So this mass we know 5%, that is 5 gram. Okay. And the molecular mass is 5% of the non-volatile solute. You have to calculate. Here, what is mass? That is 10 gram per decimeter cube. 10 gram per decimeter cube. That is 10. What is molecular mass? Molecular mass is 60. So just calculate this M. What this M comes out to be? M comes out to be 5 into 60 upon 60. That is 5, right? Now, in this question, mass is 10 gram per decimeter cube. So what do you mean by this term? 10 gram per decimeter cube, right? So you have to multiply this thing. You have to multiply this thing by 100. So finally, you'll get the answer is 300 gram per mole. right? So just use the same concept. 10 gram per decimeter cube. Just remember this. The solution containing 10 gram per decimeter cube of area. So this is the, 10 gram per decimeter cube. Okay. So we can convert na decimeter cube into 10 gram per, into the gram. So just divide by 10 raised to the power 3. So in solving, you'll get this. So the final answer comes out to be 60 into 5, right? That is 60 into 5. So that is 60 into 5. And this is M. So this will 60 into 5 and this is 6. Oh, something we did wrong. Yeah. So this will comes out to be 60 into 5 and this will cancel. So molecular mass comes out to be 300. Okay. So 300 will be the molecular mass. So now 86. Equal masses of methane and oxygen are mixed in empty container at 25 degrees. The fraction of the total pressure exerted by the oxygen is. So equal masses of all this are taken in container. Mhm. So you have to just calculate the value of this all. So what is the value of this comes out to be beta? It's a very simple, that is 1 by 3. Just try to solve. Many of you solve this question. This is a very easy one. Just use the which law? Dalton's law. Right. So total pressure exerted by the oxygen is this. That is 1 by 3. Now move to the question number 87. So what the 87 question asks, O2 is bubbled through water at 293 Kelvin, assuming that O2 exert a partial pressure of this, right? Calculate the solubility of O2 in gram liter where Henry KHO2 is given. Henry constant is already given. So you have to calculate the solubility of O2. So how will you calculate this? So we know that basically for this, how will you calculate this? So we know partial pressure of O2 is nothing but the Henry constant multiplied by the mole fraction of O2. Hmm. So now from here you will calculate the mole fraction of O2. So mole fraction of O2 that comes out to be partial pressure of O2 divided by KH. So it comes out to be 0.98, value is already given, and that is 34840. Right. So the mole fraction of XO2 comes out to be 2.81 into 10 raised to the power minus 5. Right. This is the mole fraction. Similarly, the number of moles of H2O in 1 liter. कितना होता है सबको पता है? That is 55.5. Hmm? So what is the mole fraction of O2? The mole fraction of O2 is nothing but number of mole of O2 upon number of mole of O2 plus number of mole of water. So just put the value on solving, what you will get. Hmm? So on solving, you will get number of mole of O2, number of mole of O2 plus 55.5, and X naught we know the value of X naught now. That is 2.81 into 10 raised to the power minus 5. So from this, you'll calculate number of mole of O2 very easily, right? So how does it come? So it comes out to be 1.56, 10 raised to the power minus 3 moles. So this is the number of moles of O2. Now, solubility of O2. So solubility of O2 is equal to 1.56 10 raised to the power minus 3 into 32. So it comes out to be 0.0499, or we say 0.05 gram per liter. So 0.05 gram per liter. Yeah. A. So A is the absolutely correct answer for this question. Hmm? Good. So this is how we can actually find this. Move to the next question, that is 88 question. So relation between the volume of the gas 2 that dissolve in the fixed volume of the solvent 1 and the partial pressure of the gas is 2 is NT. So total moles K1, K2 of the Henry constant are. So you have to relate the relation between this. Okay. So by the Henry's law, we know that P is equal to X, that is mole fraction, into KH. Hmm? So this is for this, and for the solute P2. So this is for P1, this is for P2. It comes out to be X2 into K2. Hmm? Mole fraction is what? So we can calculate mole fraction. So we can calculate mole fraction very easily. That is comes out to be N2. Wait. That comes out to be N2 divided with what? That is N1 plus N2 into K2. Okay. So this what we know. So from this we can calculate that is P2 is nothing but N2, and this we all write as what we write N2, and this will become what? Because this is P2 and this is N2 upon N1 plus N2. So that is N2 into K2 upon N1. So N2 into K2 upon N1. Because N2 is very, so we can just neglect this. Also, we know P2 is equal to N2 RT upon V. So just equate this and this, you get the answer. So what you'll get? You'll get N2 RT upon V is equal to N2 by N1 into K2. So from this, you'll get the V is equal to N1 RT upon K2. Right. So this is the expression what you have. So expression A is absolutely correct. Now let's see the next question, that is 89. The Henry law constant for the solubility of N2 gas in water is 298 Kelvin is 1 into 10 raised to the power n. The mole fraction of N2 in the air is 0.8. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin and 5 atm pressure is. So you have to identify this only, right? So again, this question is from the Henry's law. Let's see the solution. So we know that the partial pressure of N2 is P dash, right? So partial pressure is nothing but the total pressure into the mole fraction of N2. So what is the no partial pressure of this comes out to be, the partial pressure of nitrogen, that is N2 P dash, comes out to be 5 into 0.48. So it comes out to be 4 atm. Now from the Henry's law, we know that Pn2 is nothing but Kh into mole fraction of N2. Hmm? Chalo. So what is the mole fraction of N2 from this? So this equal to Kh upon P dash N2. Hmm? Now it is given 4. What is this? That is 1 into 10 to power 6. So this comes out to be 4 into 10 to power minus 5. So this is the value of this. Now we, if you get the mole fraction, you get the mole fraction now. Now we know that mole fraction of N2 is equal to what? The mole fraction of N2 is equal to number of mole of N2 upon number of mole of N2 plus 10. So this we get 4 into 10 to power minus 5, and this approximately equal to 4. This approximately equal to number of mole of N2 upon 10. This will be neglected. Since N2 is very less than 9. So just we calculate number of mole of N2 is 4 into 10 to power minus 5 into 10, or we say 4 into 10 to power minus 4. So this is what we can. So this is the correct one. Now let's see the last question of this chapter. That is the freezing point of the benzene decreased by 0.45 degrees Celsius when 0.2 gram of acetic acid is added to a 20 gram of benzene. If the acetic acid dissociates to form a dimer in benzene, we have to calculate the percentage association of acetic acid, right? So you have to calculate the percentage association. So what given that in this question? So delta TF is given. It is equal to 0.45, right? So this is equal to 0.45. So delta TF is already given. This is equal to 0.45. Now we know that the pressure in freezing point is what? This is equal to nothing but I into Kf into molality. So this value is given 0.45. I you have to calculate. Kf we know we have 5.12. And for molality, we know all the value like 0 mass of the solid 0.2, molecular mass 60 into 20 upon 10 to the power 3. Okay. So from here, you'll calculate I, which comes out to be 0.527. Calculated I, right? Now, in case of association, what we have like CH3, COH, and this is CH3, COH2, dimerization taking place. So if the degree of dissociation is alpha, this is alpha by 2. Hmm? So what is I beta? So I is nothing but the total number of particles after association, that is 1 minus alpha plus alpha by 2 upon before dissociation, that is 1. So it comes out to be 1 minus alpha by 2. So this is I. So from here, I comes out to be 1 minus alpha by 2. So we know the value of alpha and all these things. So alpha from there, we came alpha comes out to be 0.946, or we say 95 percentage. So what is the correct option? That is 95 B. So B is the correct answer for this, right? So this is how we can solve all this question. तो हमने इसमें सभी क्वेश्चन को सॉल्व किया 45 to 90, है ना? So I hope you like this video. So इसको अच्छे से करो, प्रैक्टिस करो, just try to solve more question, and जिन्होंने भी गलती करी है, try to rectify this, learn from this, and try to do better in the next exam, right? So till all the best, take care, and try to just revise this all this thing.